right, folks. Thanks for joining this session here. This session is titled Challenges with Preservation of Standard Bridges. Last year, we spent a lot of time talking about our whales, our major bridge structures, and we thought it would be useful to hear from states and get a perspective on what we're doing on our standard bridges, our typical bridges, our non-whale or complex structures. So that's what this session is focused on, and we'll get straight to the first presenter, Graham Bettis, who's the state bridge engineer at TxDOT, and he'll be presenting on identifying and addressing deteriorated steel and timber piling. Please help me welcome Graham Bettis.
All right, good afternoon. Pleasure to be here. Gonna try to move through this pretty quickly. It's a bunch of slides, but it's mostly photos, so that's the good news. We talked a little bit this morning. We had the new member luncheon, and one of the things we talked about during that was I think one of the good things about this group is we're willing to talk about some of our warts and failures, and you're going to see a couple of warts and failures from Texas today. Actually going back, so it's going to be identifying and addressing deteriorated steel and timber piling. Those old timers out in the crowd may or may not remember in Baton Rouge 2019, I gave a presentation on the importance of following up on bridge inspection findings. And the focus of that presentation was really on debris buildup and bearings and piling, and really particular attention given to severely deteriorated steel and timber piling and kind of what we were doing. So this is kind of a to be continued presentation on where we've landed since then. We have made a lot of progress, but if you were there in 2019, you actually saw some of these early photos. So these photos are from that Baton Rouge presentation. You can see some pretty gnarly looking timber piling there. This is a good one. So you see the 2016 routine safety inspection, broomed timber piling. Maybe some of you NHI experts can tell me what broomed means. I never quite got that one, but 2 years later, you can see what it did. So that's no good. That's pretty gnarly looking within 2 years. So that is not what you want out of your bridges. And then this one in particular got a lot of attention in our world. This is a 2012 routine safety inspection photo. You can see not much water, but it is a couple of feet of water. Not enough to have an underwater inspection, but the water is there. 2014, you still got some water there, still no underwater inspection, and you can see some funky things starting to happen with your steel. 2016, we're just not going to bother to get in the water at all. The routine safety inspection, they forgot their waders or whatever, so they took a photo for us from the bank, so way to go. All right, here we go. 2018, it finally dries out and we see what it looks like underneath that water line. And you can imagine this is not what we wanted to see, and this is not an isolated case for that bridge. It happened on every one of the steel piling. This is an urban area. This is actually just a couple miles outside of downtown Dallas. We did an emergency closure of this bridge, not what we want to have happen, right? And so this bridge was talking to us for a long time, and we weren't listening. We weren't doing thorough enough inspections. Just because it wasn't programmed for underwater doesn't mean you shouldn't be getting in there and seeing what was going on, so that's no good. Here's from, this is actually a different bent. So this was widespread within the bridge. So now that we're sufficiently freaked out, what do we do about it? This one really, truly did get our attention back in 2018. So our statewide bridge program manager, bridge inspection program manager, sent out an email to basically everybody that has anything to do with bridge inspection. That's internal, that's consultants, that's the districts, that's everybody, and really just kind of reset a number of things, including what our expectations are on these kinds of situations where there's some water but not a lot of water. And we said you really need to get in there and truly inspect those. So whether you're using waders, watercraft, whatever, we don't care, but you got to get in there and look at it. And sounds obvious, but this was not the only case where this didn't happen. We were seeing a number of examples where if there's just a few feet of water, it's not programmed for underwater inspection. We were not getting in there and doing a thorough enough inspection below the water. So something else interesting too, we wanted to measure and report remaining section and stop estimating section loss. We were seeing a lot of estimated section loss that wasn't even remotely accurate. So this went out on June 18th, 2018. 6 days later, I guess this is the equivalent of knocking on wood, or I don't know if we can see the future or what, but this happened. And you can't see a whole lot here what's going on, but you can certainly see that bump in the road. If you're really bored tonight or need some help falling asleep, go back and look at my Baton Rouge presentation. It's online. I've actually got a video of a couple of cars going over this thing, and the way we found out about this was because we got several calls from the public saying, hey, your bridge is a roller coaster today. It wasn't yesterday. You can see that really nasty looking water in the creek there. So we closed it immediately, and the phone call came in early that morning, and as we were sitting there kind of scratching our heads trying to figure out what possibly could have happened, because we were getting the dewatering stuff out there, so we had a little time to think about it, and we thought it had to have settled. Like, why would this have settled? Because it's got to be settled, man. It couldn't possibly have buckled. We couldn't possibly have buckled steel piling. We got buckled steel piling. This one scared me to death. It still scares me. I lost a lot of sleep over this one. This is as close as we've ever come, as far as I know, to actually losing a bridge, not because of a flood or a truck impact or something like that, just through sheer deterioration, corrosion. This is the closest call we've ever had. And thank God it's a continuous span over this, or else I don't know what would have happened if it was a simple span. So anyway, we were already paying a lot of attention to this, and then this happened, so we went up to an 11 in the response and really what we're thinking. So back to the estimated section loss. We had the previous routine safety inspection, we had an estimated section loss of 10%. So you can see there, I mean, pretty obvious, right? It's way, way, way more severe than that. And I think this was another case where we had just enough water to be a problem, but not enough to get us an underwater inspection. Here we go again. So just more photos. I've given entire presentations just on this bridge. It freaked me out that much. So, all right, step one was a bridge program manager sending out something. Step two, very quickly after that, less than a month later, the state bridge engineer, my predecessor, sent out a bulletin, a more formal bulletin, emphasizing and really strengthening the previous message from the bridge inspection program manager. We included information on those two closures, the one in Dallas and then the one that I just showed there with the buckled piling. And I really wanted to clarify expectations of inspectors with some significant additions on what we communicated in the past. And we want to add a requirement for underwater inspection. Even if there's if you got 4 feet of water, we want an underwater inspection. If there's any debris blocking you from getting up and doing a close-up inspection, we want that reported as an urgent finding, meaning that we want the debris removed and we want to get back out there within 6 months and perform another inspection. We can't use debris as an excuse for not getting out there and looking at it. We also want to evaluate the full length of the piling from the cap to 2 feet minimum below the splash zone. And here again, this bottom bullet, reporting measured section remaining, not estimated section loss. We were saying over and over and over again, 100% section loss. That really doesn't mean anything. All section loss is 100%, right? So we want to know how much remaining section we have. So, you know, you guys have all seen this. We're not rocket science here. Just take whatever tools necessary you need to measure remaining section and stop looking at something and being like, I don't know, 10%. And we created some forms, too, that we wanted the inspectors to use to make sure that we were getting accurate information there. Okay, so step 3, we want to identify all deteriorated steel and timber piling statewide, July 18th. So you may get a sense of just how seriously we were taking this. So the first bulletin from the inspection program manager happened in June. We were moving very, very quickly at this point because it was that buckled steel piling really got our attention big time. So we really wanted to start cataloging all deteriorated steel and timber piling across the state. We included on and off system. We really didn't care about ownership. We weren't treating this as a maintenance issue. We were treating this as a safety issue. With that, we just wanted to look at what needed to be done, and if we needed to work with local governments, and so be it. We used a substructure condition rating of 5 or less to generate the initial list, and what you can see there is our first list was 863 bridges identified. Majority of those being off-system, but a good number of on-system as well. So there's a map showing where these are. No surprise there. On the east side of the state is where the people live, and it's where the water is too. We don't have many people or much water in West Texas. All right, step 4. This was a fun one. I'm glad this wasn't me, but now it was bridge folder review time. So you take those 800 and whatever bridges and literally pull the folders, the inspection folders, and start going through every one of them one by one. And the goal really was to determine how severe the deterioration really was, because what we were finding was inspectors could have or should have found severe deterioration that was not reported as a critical finding, something that we need to step in and do something pretty quickly. So that last bullet, that's what that really allowed us to do. It allowed us to address the most serious conditions immediately, while at the same time developing a program to tackle the others. And our moderator of this session has been responsible for that effort. So really, he should be giving this presentation. So here's where we landed. I'm not going to go through all these numbers. The one highlighted yellow probably is really where you need to key in. Out of the 800 and whatever, we got down to 157 bridges that we really thought some kind of repair was needed. You do see we found 24, which should have been critical findings, and we had 4 bridges that we closed. So, you know, that's the idea, right? Find the needle in the haystack. We're not concerned about the 860 whatever. We're concerned about the 4. We're concerned about the 1 that might fall down. And so that was what the initial effort allowed us to do, is go and find the ones that could have been a problem. All right, step 5. So now we've got all the information. What do we do now? We formed a working group, and we got to it. So we wanted to move to implementation, right? We didn't want to just keep on checking folders and data and things like that. So we really wanted to move on this. So we met frequently to kick things off. Working group consisted of lots of different folks, a big cross-section within the division, because we did want a lot of input on this. The bridge program management, they've got the programming, they've got the data. Most importantly, they've got the money. Our bridge inspection program manager, of course, and some of his staff, and then the bridge preservation engineers. They got the boots on the ground, and they got the repair expertise, what really needs to be done on a bridge-by-bridge basis to address this. This is actually an older photo. I took this photo long before any of this happened. It shows what we used to do a lot of, and that was cleaning and coating and welding on steel plates. This is good. It's effective. It works. It works fine. So we still do some of this, not as much as we do this, though. Concrete encasement we have found to be very, very effective. It's very quick. It's very, very inexpensive. We really like it. And in terms of moving the needle, it's a great way to do it. So here's an example of a substructure. The condition rating went from a 5 to a 7. You can see the cost there, $2,000 per pile. That's peanuts in our world. You guys involved in the plan development side and bidding for bridge rehab projects, $2,000 is nothing. So the idea that we can get an entire bent done for like 10, 15 grand is terrific. Here's another one. So you can see on the left there what it looks like, and on the right, this project is actually underway now. It's currently a 5. We fully anticipate that it'll be a 7 when we're done. Here again, $1,700 per pile, peanuts. I hope Robbie's in the room for this next one. The video that he showed this morning, his underwater supervisor talked specifically about this issue, where you've got the concrete encasement, and they would go underwater to see if they actually did what they were supposed to do. And he would not be pleased were he to see this, just like we weren't pleased to see this. It really doesn't do nearly as much good if you don't get down below the ground line. So this one was a miss, total fail here. So, you know, we got the condition rating from a 5 to a 6, but how much good did we really do? I mean, we probably helped a little bit, but we got a stubby little piece of concrete that I don't think is going to last us long. So not only did you do a cruddy repair, now you've made it a lot harder for us to go in and do a good repair. And you can see this one actually starts getting up there in price. This is close to $5 grand a piling, and far and away the worst job that was done of the examples that I gave. Okay, and we're going, right? And you know, Don talked a little bit about this. The clock doesn't stop. Just because we started an initiative doesn't mean that bridges stop deteriorating. We don't stop having problems. So there's always new bridges being added to the list. And sure enough, we had another close call in April of 2020. This was identified some corrosion during the routine inspection. The 2018 inspection report said repair needed. I agree. April 7th, 2020, so 2 years later, this did turn into a critical inspection finding. The next inspector took it much more seriously than the previous one did, and we closed this sucker. We don't really mess around with these anymore. When we see this kind of deterioration, we get it closed. Just to kind of show you a little bit of progress, this is as of May 2020. That's about 2 years after we generated that initial list. So I mentioned 157 bridges that needed to be repaired. We hit about half of them. That's good. We would have loved to have hit more, but you know, we got about half of the ones identified. So we're cranking on these, right? Not out of the woods yet, though. So this is another one. Same deal. Bridge had a repair needed note included in the inspection report. And you'll see it happen in 2018. That's not really coincidental. These things were happening before we really started raising the alarm bells. And so I think this is a sign that our inspectors got the message. Like, you take this seriously. And so we were seeing in 2019, 2020, 2021, a lot more critical findings because I think they were paying more attention to this. But here we go again. We did follow up with the district in April 2020. The response was they're looking into repairing. 2 months later, turned into a critical inspection finding. I can't remember if we closed this one or not, but really just kind of highlights again that we got to take these things seriously, and we got to act quickly. We can't once you start deteriorating to that level, things do progress pretty quickly. So updated list, steel and timber pile assessment, June 2020. So we generated a new list, an updated list of bridges, steel and timber piling, substructure rating, condition rating, lowered to a 5. So this is bridges that we've added to the list. And again, kind of back to what Don was talking about in his presentation with the poor bridges. There are always new bridges coming onto these lists. And so 53 and 129 is what we'd added since our initial list. So that's a lot of bridges coming on a regular basis. We started specifically looking for these recommendations of repair needed. And so we could really dig into those and find out, okay, was this another case like that other one that it really should have been a critical finding? This presentation was supposed to be about steel and timber piling, right? It's been all about steel piling. Our approach to addressing deteriorated timber piling, it's a little different. It's a little more simple. Here's a screenshot of an advanced funding agreement that I just signed a couple of weeks ago. You can see it's timber. You can see that the substructure rating is a 3. There's a photo of it. There's a note, 75% decay loss. We don't really think about this one. What do? We replace it. We just don't really mess around with these too much. We've got a lot of these older bridges, especially off-system with the timber piling. When we start seeing notes like 75% loss, things like that, we just replace it. Something that Stephen and his group have done a lot of work on the last couple of years and a lot of progress on is developing working drawings. And Stephen has actually given a couple of presentations, I think a lot of you have probably heard it, on our effort in developing these working drawings. But one of the main things that we did, and one of the first things that we did, was to develop working drawings for this pile repair detail. I think you're probably getting the message. We really like concrete encasements. They're fast, they're inexpensive, and they're effective. And so what they did on this sheet was give a few different options on how to do it. We want it's not rocket science. This is really pretty simple, right? And so we beef it way up with steel. We've got a lot of steel reinforcement in there. We throw some corrosion inhibitor in the concrete. That second bullet there, good grief, extending the encasement length minimum 2 feet above and below the distress area or ground line. We really don't want that circumstance that Robbie's Guy described where the piling doesn't go down to the ground, that photo that I showed you where it stops short. So just a couple more photos here. Here's some more successful concrete encasement, and the arrow on the right there, err on the side of too many encasements, not too few. Something really interesting about that bridge that I showed you with the buckled piling, some of those steel piling had concrete encasements. Clearly, they did not go far enough in adding those. You're there, it's really inexpensive, just put more than you think you need them. Channel shift, water shifts, so just do it everywhere. I mean, while you're there, you might as well. Last couple of examples here, one more before and after, really slick, really easy, fast, effective. Part of our goal with this, we do rely a lot on contractors, but we're also really trying to up the game in the amount of in-house work that we've done. We've heard a number of presentations as part of this conference, and you look at what the Arkansas DOT does and what the Louisiana DOT does, and you see that they've got a lot more in-house capability than we've had. And so we're really trying to increase how much work we're doing internally, because you can do it at just a fraction of the cost, and you can do it much, much, much faster. And so that's one of the reasons, one of the goals of the working drawings was to keep it as simple as possible, so our maintenance crews would be willing to get out there and do it themselves. I'm going to go just very quickly through my last couple of slides. Current status. So every couple of years, we're updating our list. We started it in 2018, we updated it in 20, we updated it in 22. We'll have another update coming next year. Really just trying to continue getting the message out, making sure everybody understands how important this is. This is not one of these things that can be ignored. We can't lose a bridge. We got to be better than that. Did y'all see that? Or cancel that? I'm gonna hit cancel. Oh, shoot. Well, y'all can still see the presentation. All right, sorry about that. We want to integrate this into our database, and we want to stop having to do this by hand. We will keep doing it by hand as long as we need to, but we've got our data wranglers more involved in this process now. And really just to show you that bottom number there, we have addressed a very large number of bridges as a result of this effort. So we've repaired, golly, I'm not going to try to do math in front of everybody, hundreds of bridges have either had that encasement, so primarily either had the encasement or been replaced. And you know, I'm not going to go off on a tangent here, but I really enjoyed hearing Don's presentation this morning on the bridge replacement program, because in my opinion, replacement is a huge part of bridge preservation, and really taking a step back and trying to figure out where does it make sense to preserve versus just replace that sucker. And you can see where we land on that. We replace a lot of these bridges. Takeaways: one size does not fit all. Same point. You gotta look at this on a bridge by bridge basis. There is no one size fits all. I think you've heard me say it about a dozen times. I'll say it one more. Concrete encasement is awesome. We love it. Go with the change orders. Within Texas, it just for a while, it seemed like if you got a change order on your project, then you were just a miserable human being, like you had screwed up bad. Like in these kinds of projects, change orders are reality. So just accept them and don't fight them, because if you fight them, you're not going to get the work done. Inspection. Avoid that failure of a project that I showed you where the piling didn't even get to the ground line. It's hard to get inspectors out to jobs right now, especially on these smaller dollar ones, but if you don't inspect it, that's the kind of quality you can expect. This is an ongoing effort that requires championing at a statewide level, so we're going to keep getting the message out, and that is it. So,
No, TxDOT shifted repair recommendations from paper forms to the maintenance module through the inspections. Have you seen that make it substantially easier to respond and or track the situations like this to get those numbers down and get them down quicker?
Yeah, absolutely. You're kind of stealing my thunder for the presentation that I'll give tomorrow. But yes, absolutely, the maintenance module has been a big part of it.
So Graham, yeah, we're same in Georgia. We like encasements. Like to not do them after the fact, but same as you. But one thing we're seeing too, I was wondering if you see it, we're seeing some instances where it's at the top of the pile, where you got the cap and the H pile. You get corrosion there. Are y'all seeing that?
Not too much. It really, the common factor, the most common factor is that 2 or 3 or 4 feet of water. And so stuff that is wet and dry over and over and over again, it's not getting underwater inspection, it's just kind of in the muck. That's really probably the most common factor for us. We haven't seen a whole lot of deterioration towards the top.
Just out of curiosity, Georgia, what kind of H or steel to concrete cap connection do you have that you would be getting that kind of deterioration at the cap? Is it
Don,
encased?
that one's for you, buddy, or one of your folks.
Say that again?
The pile cap connection. How is your pile connected?
Oh, all our details for years and decades is the pile embedment, a foot into the cap.
My question is it from, like, is there something above that that's leaking through? Is there somehow getting salt? Yeah, I mean, that would be my thought, is that if the water's coming down through the joints, perhaps that's,
We're debating whether it's just you paint that pile and then encase it, and then you don't have that pile.
We got Tennessee now.
And maybe just this one last one before we move on.
Regarding your concrete encasement, do you guys do a hydraulic model to see exactly how high you need to get to the water line before you actually do the repair?
We don't. Listen, it's a little archaic. There's not a whole lot of design going into these encasements. We've seen it work. You know, we go a foot or two more than we think we probably need to, but it really is more by feel. There's not a whole lot of engineering analysis that goes into the encasements.
All right, folks, let's give Graham a last round of applause.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.